Hi, I am Nur Aina Nazifa binti Muhammad Shukri. My matrix number is 2022881648.
Hi, my name is Nurshida binti Soini. My matrix number is 202245206.
Hi, my name is Ali Ardani and my matric number is 2022846564.
Hi, my name is Nur Shafika binti Salman and my matric number is 2022846356. So, for the introduction laws of logic, fundamentals of logic revolve the systematic study of the governed rational thought and sound reasoning. Logic deals with proposition, logical connective, truth, values, arguments, various types of reasoning. It allows us to assess the validity and soundness of arguments in making clear decisions. These basic understandings of logic can be applied in various areas and plays an important role in every problem solving.
Okay, so we're moving to the next slide, which is descriptions of concepts. For law of logic. Usage of concepts of logical equivalence, tautology, contradiction, and also various lists of rules for algebra proportions. For manipulating logical expressions, which are crucial in constructing valid arguments, proving theorems, and solving problems.
So, there are 12 laws. The V sign represents OR, which means disjunction statement, and the downward V sign represents AND. It means that conjunction statement. The first law is double negation. The double negation of P is equivalence to P. The second one is De Morgan's law. The negation of P or Q is equivalence to the negation of P and the negation of Q. Same goes to the negation of P and Q is equivalence to the negation of P or the negation of Q. Third, commutative law. P and Q is equivalence to Q and P. Same goes to P or Q is equivalence to Q or P. The fourth one is associative law. P or Q or R is equivalence to P or Q or R. Same goes to P and Q and R is equivalence to P and Q and R. Just move the bracket when it comes to same symbol. The fifth one is distributive law. P of Q and R is equivalence to P or Q and P or R. Same goes to P and Q or R is equivalence to P and Q or P and R. We can use this law when the two different symbols included in the statement. The sixth one is idempotent law. P or P is equivalence to P. P and P is equivalence to P. 7. Identity law. P of false is equivalence to P. P and true is equivalence to P. 8. Inverse law. P or the negation of P is equivalence to true. P and the negation of P is equivalence to false. 9. Domination law. P or true is equivalence to true. P and false is equivalence to false. 10. Absorption law. P or P and Q is equivalence to P. P and P or Q is equivalence to P. 11. Definition of implication. P implies Q is equivalence to the negation of P or Q. Last but not least, definition of biconditional. P if and only if Q is equivalence to P implies Q and Q implies P. Equivalence to the negation of P or Q and the negation of Q or P.
So now we are going to look at the first example, which is we get it from the past year paper, September 2015 for MAT code 222 from question 3A. So the question asks us to simplify the following statement using the laws of logic. The given statement stated as not P and not R, or R or not Q. We need to show that the statement is equivalent to the not P or not Q or R. Okay, first of all, as mentioned by Moshidah just now, the V sign of the statement shows that it is a disjunction statement, or we can call it as OR, and the upward V is represent as conjunction statement, conjunction symbol, and we can represent as N. So now we are going to look at the question. The first law that we use is associative. That is because if you look at back from the formula that explained by Moshidah, you can make it as a P, Q and R equation, which is you group the first one, not P and not R statement, as a P, R as a Q, and not Q as a R, so that we can conclude that they have the same disjunction statement. That's why we can use associative law. From the second row, we use distributive law. That's because they are in the same statement of not P and not R or R, and with a different conjunction and disjunction. That's why we use distributive. How can we use distributive? It's just the same as expenditure of a maths equation. We expand not P and R with the R statement itself. For the third row, we use inverse law. That's because we can see that there is a not R or R equation there. So that's why we need to use inverse law. From the fourth row, we are using identity because there is a T, which is, we can call it as tautology. For the statement in the fifth row, since we have the same equation of the statement between not P or R and or R or not Q, they have the same disjunction statement. That's why we can use associative law, so that we can arrange the position of the statement itself, which is from not P or R or not Q, we arrange it as not P or not Q or R. So it shows that not P and not R or R or not Q is equivalent to the not P or not Q or R. So the statement has been proven.
Okay, next is example 2, which we got this question from past year April 2008, MAT222, question 5B2. So the question is not P and Q, or P and not Q, or P and Q. We have to use the law of logic to simplify the statement. So as we know, at the back of the question, we can see that we have the same statement of P and different statement of Q, which is not Q or Q. So we know that we can combine the not Q or Q using distributive law. So the first step is we use the distributive law. So the statement will be not P and Q, or P and not Q or Q. So we done combine the not Q or Q. Next, we will use the inverse law, which is the not Q and Q will turn into true. So the statement will be not P and Q, or P and T. We know that we can get only P if we use identity law. So the next statement will be not P and Q, or P. So next, we combine the not P and T using distributive law to be the new statement, which is not P or P and Q or P. The next step is inverse law. Just like the second step just now, we turn the not P or P turn into T. The new statement will be T and Q or P. So using identity law, the last statement will be Q or P. So the answer is not P and Q, or P and not Q, or P and Q is equivalent to Q or P.
So, we move to the example 3. We take the question from the past year papers, January 2018, MAT210, question 5B2. This question asks us to simplify the following statement using the laws of logic. The question is not P implies Q and not P or Q. For the first step, we need to apply definition of implication. It is because the statement of not P implies Q, we need to change to not P or Q. So the answer is not P or Q and not P or Q. For the next step, we need to apply double negation law. It is because the statement of not P or Q, we need to negate, so the answer is P or Q. For the answer is P or Q and not P or Q. For the third step, we need to apply commutative law. It is because we need to exchange P and Q. So the answer is Q or P and Q or not P. So the next step is we need to apply distributive law between the two statements, Q or P and Q or not P. Between two statements, we have the conjunction sign. So we need to apply the distributive law. So the answer is Q or P and not P. For the second last step is we need to apply inverse law. It is because we have the P and not P. So the answer is Q or F. So the last step is we need to apply identity law because of Q or F. So the answer is Q. Therefore, not P implies Q and not P or Q is logically equivalent to Q.
So we have come to the end. Now I will conclude it. In conclusion, what we need to do in order to master the law of logic, we need to memorize all the law. There are 13 law of logic such as double negation, De Morgan's law, commutative law, associative law, distributive law, idempotent law, identity law, inverse law, domination law, absorption law, a definition of implication and definition of biconditional law. We can apply the following list of law, name the laws of logic to establish the logical equivalence. And we also learn how to use law of logic to simplify logic statement and learn way to prove logically statements using the law of logic.